Next, we're going to look at an example of a limiting reagent problem. Question number 1 says, magnesium metal will undergo a reaction with a solution of zinc 2 nitrate to form zinc metal and aqueous magnesium nitrate. Calculate the mass of zinc that can be formed if 2.43 grams of magnesium metal reacts with 3.75 grams of zinc 2 nitrate. As we look at the information in the problem, the very first thing we need for this limiting reagent problem or any stoichiometry problem is a balanced chemical equation. So that as I go from the information in the problem to all of the correct chemical formulas, the balanced chemical equation that I have tells me that 1 mole of magnesium plus 1 mole of zinc nitrate yields 1 mole of zinc metal and 1 mole of magnesium nitrate. I have a 1 to 1 to 1 to 1 mole ratio for my components. Remember that your balanced chemical equation relates each of these components in units of moles, and so now the next thing that we're going to need to do is we're going to need to convert each of the starting materials to moles. We know from the information in the problem that 2.43 grams of magnesium is what we're starting with. We can convert that to moles using the molar mass of magnesium. So that's going to be 24.31 grams per 1 mole right from the periodic table. So that tells us that at the beginning of the reaction we have 0.100 moles of magnesium. Next, we know that we have 3.75 grams of zinc nitrate in the reaction. We also know that 1 mole of zinc nitrate has a mass of 189.36 grams, so that when we convert to moles, we know that we have 0.0198 moles of zinc nitrate at the beginning of this reaction. Now, just like we did in the cookie exercise, what we need to do is we need to relate each of these amounts of starting material to that amount of product. How much zinc can this amount of magnesium make? And how much zinc can this amount of zinc nitrate make? So the next thing we're going to do are both of those stoichiometric calculations. I'm going to take my 0.100 moles of magnesium times my conversion factor, which needs to allow me to cancel my units of moles of magnesium, and I need to end up with moles of zinc, which is my product of interest. When I do that calculation, I get 0.100 moles of zinc, and that's the maximum amount of zinc that can form based on the amount of magnesium that I'm starting with. Remember that I can form any amount of product that is less than 0.100 moles of zinc, but I can't form anything more. When I do the same type of calculation for my zinc nitrate starting material, I have 0.0198 moles of zinc nitrate. I know from the balanced chemical equation that 1 mole of zinc nitrate allows me to form 1 mole of zinc. So that if all of this zinc nitrate is converted to zinc, I would expect to isolate 0.0198 moles of zinc. That is the maximum amount of product that can form based on my zinc nitrate starting material. I can form any amount less than that, but nothing more. So now for the key part in the problem where we're going to compare these two amounts of products. This is a maximum amount of product based on magnesium. This is a maximum amount of product based on my zinc nitrate. I'm looking for the lesser of these two amounts. This tells me that I have enough magnesium to form 0.100 moles of zinc. When I look at the amount of zinc nitrate that I have in the reaction, I don't have enough to form that amount of product. So again, as I compare these two values, the smaller of the two values is important because this is now the value that's going to tell me how much zinc I can actually form out of the reaction based on the amount of both of my starting materials that I have. So that means that in this reaction, this 0.0198 moles of zinc, this becomes my theoretical yield. That means over here that my zinc nitrate is going to be my limiting reagent. That also tells me that my magnesium is going to be present in an excess, meaning some of it gets consumed and some of it's going to be left over at the end of the reaction. Finally, once we know our limiting reagent, our theoretical yield, and our component in excess, we can answer the question that has been asked, and that is to calculate the mass of zinc that will form. If I know This as my theoretical yield of zinc in units of moles. I can convert that to grams in order to calculate that mass. So I'm going to take my 0.0198 moles of zinc times the fact that 1 mole of zinc has a mass of 65.39 grams, and that tells me that I expect to isolate out of this reaction 1.29 grams of zinc. This is my theoretical yield in units of grams. This is my theoretical yield in units of moles. Now, finally, a pretty typical question for a lot of these problems that we'll be working looks like this alternative question I have listed here that asks you to calculate the percent yield for the reaction if 1 gram of zinc was isolated. That tells you that in this reaction, 1 gram of zinc is what I actually isolated. This 1 gram of zinc is going to be my actual yield. When I look at my calculation for my percent yield, I need my actual yield divided by my theoretical yield times 100. So that's going to be the 1 gram that was given to me here in this alternative question divided by my 1.29 grams that I calculated up here as my theoretical yield times 100 gives me an overall percent yield for the problem of 77.5%. Now, question number 2 in your packet looks at the reaction of iron 3 chloride and ammonium hydroxide. I've given you the balanced chemical equation. I've walked you through the steps in this problem. I want you to now solve this problem on your own. Pause the video and solve this problem on your own.